Today we are going to talk about probability. The probability of something happening is taking the desired outcome, the thing that we want to happen, and dividing by the total number of things that could happen. Okay. Probability is a value between 0 and 1. A lot of times people will turn it into a percent and say there's a certain percent chance of something happening, but technically probability should be a fraction or a decimal number between 0 and 1. 0 means there is no way that thing is going to happen. And 1 means that thing has to happen. And then anywhere between there tells us the likelihood of it happening. We are going to begin by talking about theoretical probability. Theoretical probability is what happens in theory. So when you flip it, there's two options, a head and a tail. And in theory, either one has an equally likely chance of happening, unless you have a weighted coin or something. But assuming we have a fair coin and I flip it, half the time it should end up heads, half the time it should end up tails, but not exactly. Because if I flip it 2 times, I shouldn't be shocked if I get 2 heads, right? So each one is equally likely in happening, but it shouldn't be surprising if it doesn't work out perfectly that every other time I flip a coin, it's one and then the other. Now, if I flip a coin 1,000,000 times, about half of them should be heads and half of them should be tails in the long run, but in the short run, reality doesn't always match theory. Okay? I used to give an assignment with the textbook that we taught probability that had students flip a coin 100 times and write down the results. And I could always tell the students that cheated because our natural inclination is to do something like heads, tails, heads, heads, tails, heads, tails, tails, and it's all very balanced and there's no long streaks. Whereas in reality, what should happen probably at some point in there is of getting 8 or 9 of the same thing in a row. And it probably actually isn't going to end really close to being 50-50 in the short run of only 100 flips. Now again, if you do 1,000,000 flips, it's going to be more like a 50-50. Okay? But theoretical probability is what should happen, not necessarily what does happen. So if I roll a 6-sided die, and it's a fair die, so any of the sides are equally likely of landing up, part A asks, what is the probability of rolling a 4? In probability, we want the number of desired outcomes over the number of possible outcomes. So if I want to roll a 4, how many 4s are there on a die? 1 of them. And how many things could happen? 6. So 1/6 is my probability of getting a 4. Rolling an odd number. How many odd numbers are there on a die? 3. 1, 3, and 5 are odd numbers that are on a die. Out of how many things could happen? 6. Reduce fractions when possible. So I would have a half chance of that happening. Rolling a number less than 7. How many numbers less than 7 are there on a die? 6. 1, 2, 3, 4, 5, 6 are all less than 7. Out of 6 sides gives me that probability of 1, which means that has to happen. When you roll a die, you have to get a number that is less than a 7. Questions? Question, we have a spinner that has 8 sectors of equal size, so they are all likely to happen. They are numbered 1 to 8. Find the probability of spinning a 6. How many 6s are there? 1. If there's 8 sectors and they're numbered 1 to 8, one of them should have a 6 on it out of the 8 different spaces it could land in. Spinning a number greater than 5. How many numbers are greater than 5 on that spinning wheel? 3, 6, 7, and 8. When we say greater than, that means it doesn't include that number. So greater than 5 is just 6, 7, and 8. So there are 3 options there out of the 8 that would meet that criteria.
When we get the answers in our homework, should we get it as a fraction or a decimal?
I don't mind either fraction or decimal, but if it's a fraction, please reduce it when possible. Good question. We talked about is the other side of theoretical. So theoretical is what should happen. Experimental is maybe what does happen. Trying to flip a coin a lot of times, or rolling a die a lot of times, or taking a survey. So in this problem, a survey was done of internet users asking for their ages, and this was done in 1998. Find the probability that a selected internet user at random, so they just grabbed some survey out of the pile, what is the probability or chance that that person was at most 20 years old? So which category or categories meet that requirement of at most 20 years old? Under 21. So under 21 would be up to age 20, so at most 20 years old. So 1,636 people meet that criteria out of, what would I do? Add together all the options, and that would tell me how many people were surveyed. So we'd want to add together each of those categories. And that gives me 12,443. Now this doesn't make much sense to me when I look at it, like it doesn't mean anything. I know what a half means, I know what 3/8 means, those things I have a good judge for like how likely that is to happen. But when I look at this, those numbers just don't really have any meaning for me. So when that occurs in a problem, that the numbers are just big or messy, I like to turn it into a decimal so that I have a better understanding of how likely that really was. So that turns into about 0.13. So not very likely. Part B asks for at least 41 years old. So which categories work for that?
The 41 through 16, 61 through 80.
And the over 80.
Oh.
So anything above that 41 works. There aren't very many people over 80, but we'll include them as well in there. So any of those three categories work. So I'm going to add together those three categories. And that gives me 4,190 out of, again, the total number of people surveyed. And this is then about 0.34, so about 3 times as likely. Does that seem weird to you? I mean, this is about internet usage, and this is saying that people over 41 are about 3 times as likely to use the internet as somebody under 21. It was taken a while ago, right? So right now, this would be a really surprising find. Like, if these survey results came out today, I would, like, doubt the validity of this survey because you guys are on the internet a lot more than your parents, probably. But in 1998, the internet was not really a social thing. It was mainly for internet or business purposes or research or something like that. So it doesn't surprise me that the 21 to 40 was the biggest range, the most popular range in this survey, because those were young professionals at that time that were probably more likely to use the internet. And I was in high school in 1998, so I would have been in that lowest category, and it just wasn't really a social thing. We didn't spend much time on the internet like you guys do now. So pay attention to the year of data as well when you're given data. Old data is not usually very good data. Questions? 9th graders must enroll in one math class. The enrollments of the 9th grade students during the previous year are shown in the bar graph. This is not our 9th grade students. These are just 9th grade students in some fictitious class. And we are asked for the probability that a randomly selected 9th grader would be in consumer math. So how many are in consumer math?
36.
36. Out of, what do we do to get the denominator? Add them up, so we figure out how big that 9th grade class is. And this 9th grade class has 243 students in it. So to give that number some meaning, I can do the division and turn this into a decimal, and I get about a 0.15 probability that a 9th grader was in consumer math that year. Part B, Algebra 1 or Introduction to Algebra. So there we have 2 different categories that we're going to combine. So that gives us 138 out of that same class of 243. And we find about 0.57 probability that one of the students was in some sort of algebra, which is typically considered to be the standard track of ninth grade. Questions? Now, by calculating a ratio of two lengths, areas, or volumes, these are called geometric probabilities. We're just going to look at areas in our geometric probabilities, but since this is geometry, it seems like this is a good thing to do. So we're going to take the ratio of areas. It'll be the area desired divided by the total area. So number 5 wants us to compare two different probabilities. If you throw the dart with some randomness so that you are guaranteed to hit the board, you're not going to hit the wall, but it could hit anywhere on the board, are you more likely to get 10 points or 0 points? Now, if this is a good dartboard, it should be more likely to get 0 points with a random throw, right? It should take some skill to get 10 points. So what we want to say is it more likely that you're going to end up with 0 points or 10 points? So, to figure out the likelihood of getting 10 points, we would want to take the of the 10-point space divided by total area. The area of the 10-point space is a little circle. What's our area formula for a circle? Good exam review. Pi r squared. What is the radius of that little circle? It's kind of fuzzy. 3.
Wait, but it says just 3 for both clubs, so what is it?
We're looking at just that little 10-point region. Yep. Then the bottom is the total area. So that's the full dartboard, which is the entire square. Area of a square rectangle is length times width. How do I know what the length and width of this thing are?
You have that diagonal.
Measurements here of 3s. So if I add up these 3s going across, how far is it all the way across? 18. So I've got 3, 6, 9 to get me to the center, and then going across the other side would be another 3, 6, 9 to get me 18 all the way across. Since it's a circle, inside of there, the height will be the same as the width. When you plug this in your calculator, I suggest plugging in the top and then hit enter, and then doing the bottom and dividing. Plug in your pi button as well, so that we get a full decimal answer without the pi in our answer. I get about 0.087 when I divide this out. So not very likely to get 10 points. But the question is it more likely to get 0 points or 10 points? So now we have to figure out how likely is it to get 0 points. So here we would want the area of the 0-point spaces divided by the total area. The 0-point spaces are not a shape that we're really familiar with in terms of coming up with an area equation. They're not quite triangles. They're kind of triangular, but they have that curvy side. So we can't just use a triangle formula. So how could I find the areas of those 0-point spaces?
Take the area of the other circles and then
Minus the circle.
Yeah, so we can take the whole board, the square, 18 squared, and subtract out the stuff we don't want, which is up to the biggest circle. What's the radius of the biggest circle? The whole circle. 9. So we can take the full square, which would be the 18 squared, and subtract out from that the area of the biggest circle, which has a radius of 9. So pi r squared for that circle. Now again, I would suggest plugging in the top of this to your calculator and hitting enter and then dividing by the denominator. It's a little bit safer. Otherwise, you need to put some parentheses in. So that gives us about 0.21. So it is definitely more likely to get 0 points than 10 points, which is a good thing. Questions? Find the probability that we would hit the shaded region. Once again, we're randomly throwing it, so we're definitely going to hit it, but we could hit anywhere in it. So for this one, we want the shaded area. divided by the total area. So how would I find that shaded area?
Well, we know the one side is flat, so the other side has to be A if the circles are equal to each other.
Okay, so the circles fit perfectly inside of this rectangle so that the diameter must be 4 for both of them. And so if we tip that diameter on its side, it should still be 4, which would give us a length of 8 going across the bottom. So the full area would be 4 times 8 or 32. How can that help us find the shaded regions?
Well, we can take the area of the circles and minus that.
So we can take the full area and subtract out the area we don't want, which is the circles. There are 2 circles, and their area is pi r squared. What is a radius of one of those circles? 2. A radius just goes from center to edge of a circle. So pi 2 squared, and we need that extra 2 in there because there are 2 circles. Once again, for calculators, suggest plugging in the top and then hit enter and divide by the bottom. So that gives us 0.2146. As far as rounding goes, 2 to 3 places is fine for rounding your answers, or if there's kind of a place that makes sense to cut it off, then that's good too. Questions?